All right. So at this point, we have looked at how to find the lengths using trig, find the angle using trig. We've figured out how to solve for all the missing values using trig. Now we're going to look at some word problems. And yes, there are practical situations where trig gets used in real life. Unfortunately, one of the things that we have to introduce is something called the angles of elevation and depression. And these are always a source of confusion. The angles of elevation is exactly what you would think it would be. It is the angle looking up. And that one's not a problem. The problem is the angle of depression, because it is the angle looking down. And that is not usually how people think of it when they start putting these putting together the diagrams, putting together the pictures to make it work. So that tends to be the main source of problem whenever you're dealing with word problems. The angle of depression tends to be the opposite of how we intuitively think of them, even though both of them are defined the same way. They are the angle measured compared to the horizontal. So example 1. From a point 28.5 meters from a base of a cliff, a land surveyor uses a theodolite to measure the angle of elevation 73.5. What is the height of the cliff to the nearest tenth of a meter? Now, if you're anything like me, all you heard was Charlie Brown's teacher in the background going wah, 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 wah. So let's pick out some keywords. It's a cliff. Cliff. Not Cliff Clavin, for those of you who know that show, but a cliff. Okay? From a point 28.5. So we know he, she, it. It's 28.5 away from the base of the cliff. We're looking up, and we're told that the angle that they look up is 73.5. What is the height of the cliff? Uh-oh, I have a variable in there. So the first thing I do is define it. You are now defined. Now, let's solve for h. In this case, we have opposite and adjacent, so that's tan 73.5 equals h over 28.5, 28. 0.5, h equals 96.2144. Get in the habit of leaving your answer to 4 decimal places and not rounding until the therefore statement. I believe I said in an earlier lesson that a lot of these, if they're just a single question, then it's not a problem. As soon as they become multi-step questions, you're going to need those 4 decimal places for the extra accuracy. Okay, so once again, here's a pretty little question. Hot air balloon at the end of a taut 95-meter rope rises up from its platform. Rise. Sam, who's in the basket, estimates the angle of the pressure of the rope is 55. So here's that stupid phrase that I don't like, that we can't get away from. All right, so we got a hot air balloon somewhere above the ground. We know there's a rope, rises from its platform. The angle of depression is 55. So presumably this is where the platform is. Now, if it's a taut 95-meter rope, that means that this is 95 meters. How far horizontally? So we have the option of this or this. We don't actually care about the height, so I don't need that. The only one I got to define is D. But there are 2 ways you can approach this question. You can, well, okay, let's define D first. Now I chose D because I tend to think of H as being for height. I don't want to mess with that, but I could have used H for horizontal. That would have been fine. There's different ways to approach this. You could choose to solve for the angle in here, or you could remember that by alternate angles, that's 55, and we don't need this at all. So just to make it a little less messy, I'm going to remove the information that we aren't using. Now, you don't have to tell me this every time. That was grade 9. This year, I just expect that you do it and that you know what you're doing and you're doing it properly. All right, so what do we got here? It looks like sine, opposite and adjacent. No, cos, because I forgot we changed our angle. Okay. Now, you could have solved for this as well. And in fact, that's actually what I did in my solutions. I did 90 minus 55, gave me 35, and then I did cos. Cos? I did sine, I'm sorry, sine of 35 and solve for that. And it'll give you the same answer. A video camera is mounted on the corner store of a 120-meter tall building. The angle of elevation from the camera to the top of the neighboring taller building is 17 degrees, and the angle of depression is 25 degrees. So once again, I don't understand. Let's draw a short building. Let's draw a tall building on the top corner. So we know that this is 120. There's my horizontal. To the top, 17 degrees. And the angle of depression is 25 degrees. So how far apart are the buildings? Everything's in meters by, right? Because this building, this is defined as being straight across. It's also horizontal. So just to make it easier to see, that's what we're looking for. Uh, 120 over D. D equals 120 divided by tan 25. 257.3408. Oh, let's make that a little clearer. Okay, now up until now, we have never had a question that's required us to build on what we already know. But in this case, we need that 257. So h equals height above smaller building and we have the sorry guys, and we have the final answer. Now, had I been required, in this case, I probably didn't need to carry the 4 decimals, but you never know exactly what you're going to have to solve question-wise when you're going through. Had I had to solve for an angle, I would have needed that 4 decimals. So it's a good habit to carry it through. Yeah. There's your homework at the bottom. As always, if you have any questions, shoot me an email, shoot me a text, have a look at the full solution. All right, guys, enjoy.